Hello, everyone. Right, so running WebRTC on low-powered and cheap devices. I counted up my slides earlier. I have 91. That may seem like a lot, but if you've been to a talk that I've given, you know it's not. But I have about 6 slides per minute to then be able to do a demo. So it should all work out absolutely fine. So, who am I? I'm Dan Jenkins. I'm the founder of NimbleApe, a consulting company in the UK. I am the organizer of ComCon, and then I'm also the founder of Everycast Labs. And then recently, 2 months ago or so, I became the editor of the WEP spec in the IETF. Everyone else, this wasn't in my slides. Everyone else keeps talking about being part of the IETF, and I was like, I have to get my name in there. So that's what I did. NimbleApe, we're a real-time media consultancy company based in the UK. We work with companies big and small on anything real-time related. ComCon is a conference around real-time communications. It was established back in 2018, and hopefully we have plans to be back next year. We took this year off just because, life. But we are 99% going to be back next year. And it will probably be in mainland Europe around June, July time. And if you're interested in supporting such a conference, we will be looking for sponsorship soon. So Everycast Labs, we are the creators of Broadcast Bridge, IcePerf, and Dotty boards. Broadcast Bridge is a service to be able to bring remote people into production media workflows in a live sense. IcePerf, we test stun and turn networks. And Dotty boards, I will show you a little bit later. And then we also make the AV connector t-shirt that I'm currently wearing. You can go to everycastlabs.uk and buy one. Quick note on WEP. We've got a meeting, interim meeting next week. So if you've got any gripes/pain points, come talk to me because we are very close to the end. I'm just here to kind of help push it to the end. So, why am I here? Because $5, £5 chips can surprise you, because hacking on hardware is fun, and running WebRTC on low-powered devices is now very much possible. So, first things first. What do I mean by low-powered? Do I mean in terms of the amount of energy they consume? No, I mean compute resource. Compute resource means everything when it comes to, say, WebRTC, because WebRTC does encryption and everything else, and so it needs enough compute to be able to do that, to encode video, everything, and it can't just run on a super tiny device. Well, until now. So, WebRTC, what is it? Peer-to-peer magic. So you get audio, video, and data. It's open source, browser native, and it runs well on everything now. Browsers, mobile apps, native desktop apps, etc. How does it work? I'm not going to bore you with this. The flow. Everyone knows this flow, hopefully, when it comes to WebRTC. So we create an offer, we send that offer to the other device via a signaling server. That signaling server, that device creates an answer, sends it to the signaling server, sends it back to us. We exchange some ICE candidates via the signaling server, so my diagram is wrong, and then the DTLS handshake and everything happens between the devices. The SSView flow is a bit more complicated, and you end up having to deal with a lot more. But we're back onto low devices. This talk isn't really meant to be about educating you. It's about having some fun. It's meant to be semi-educational. Hopefully you'll come to the end of it and go, all right, that's good. Hopefully it might be inspiring. I think the last time I gave a talk in one of these, someone went and bought what was it? It was a Stream Deck, wasn't it? And he went and built something cool with it and then blogged about it. So hopefully you might do the same. So let's talk about cheap, low-powered devices. Let's talk about the easy ones. Linux boards, SBCs, comfort zone. Since the Raspberry Pi 3, 2 I think was possible, but it didn't really work very well. The 3 until the 5, but let's take a look at the Raspberry Pi 5. So it's a 2.4 gigahertz quad-core 64-bit ARM processor, and it has up to 16 gigabytes of RAM, which is a massive amount of RAM. And generally, it lands between 48 and 115 pounds. You'll notice throughout the talk, I switch between dollars, pounds. It was whatever it was given to me in. I'm not very good at conversions. So that's probably about $60, I think, $65 as a starting price for a Pi 5. Why is it easy? Well, it's Linux. And so you can use all the tools that are available in Linux, right? So video streams really nicely. It has hardware encoders and decoders, and it just kind of works, right? Tim's right there, and he's probably going, it's not really the case. But he's going to talk to you about that after me. But for me, it just works, right? You write some code, and a peer connection gets made. And it's not too difficult to get that going. The Raspberry Pi Zero, I haven't actually got one up here with me. So yeah, Raspberry Pi, right? So it is small. It is actually quite low powered in terms of energy, but it's actually got quite a lot of power. The Raspberry Pi Zero through to the 2W, it kind of compares to the Pi 3, roughly in terms of specs. It's a quad-core at 1 gigahertz, and it's got 512 meg of RAM. And these start at £15, so a much better way of kind of getting into building stuff. But ultimately, it runs Linux. And then we can insert loads of other SBCs in here as well. So I've got an Orange Pi Mini, I think this is, Cadus Vim 4, insert loads of others, and you can run Linux on them and, do WebRTC on them. But to me, Linux equals easy WebRTC. Again, I feel a glare from Tim over here. But we want the pain, right? We want to learn something. So now to the other extreme. And this, really, I'm going to get a glare from Tim. So now to the other extreme. Back in 2015, this is probably one of my favorite conference videos ever. Tim did a Cranky Geek event in, I think, San Francisco. And he put a Lego EV3 brick thing on the floor, and it looked like a dog. If you don't know what an EV3 is, it was a programmable thing. You plugged loads of sensors into it, and you got Lego to move and stuff like that. So the Lego EV3, it was an ARM9 processor at 300 megahertz. So not dual core or anything, just 300 megahertz. It had 64 meg of RAM, and it had some custom firmware on it to get a Linux prompt on it. Yeah, Tim Panton from 10 years ago. So I just want to play. Hopefully this is going to start at the right time.
I went out and bought myself a toy.
So this is an EV3.
I bought myself a Lego EV3. Now the EV3 is exactly that spec. It's a 300 megahertz ARM9 running Linux, and some clown it's open source, right? So some clown rebuilt the OS so that it took all the Lego stuff out, and you run a plain Linux, and then some other clown, and I just admire the open source community for this, went and put a Java API on it.
Right,
so we can move
forward a bit. So he goes and puts it on the floor, and then it takes about 3 minutes.
Right, so now...
It takes about 3 minutes from Tim getting back to...
that's a distraction.
Tim getting back to his laptop.
Right, so...
And pressing go.
Right. So I need to kill. Kill. Now I need to kill the current menuing system that's running on there.
Right, we can skip forward a little bit.
Starting Java on a 300 megahertz ARM and pulling in the DTLS crypto library. So
3 minutes later, we finally get to a good point. It's actually really good. You should go watch it.
There we go. Got it.
But
Right. So.
And then Tim
We now have
literally starts driving.
Packets are going. We now have a data channel running.
We have a data channel running. And then Tim starts driving it around this conference in San Francisco. That doesn't sound that exciting, right? But for me, back in 2015...
have I gone too far?
Let's go forward. There we go.
Turn.
Oh, no.
Back to...
There we go. Let's refresh. Let's go back to full screen. For me, back in 2015, that was like the epitome of awesome, right? Being able to get something that's doing crypto and everything else running on a device that was never even meant to run this stuff in the first place, and Tim just, waltzes and puts it down on the floor and drives it around. To me, that was really cool. And when I first started playing around with hardware, that's what kind of came to my mind. So yeah, Lego Barks, WebRTC. For me, that was hacking hardware and to do it really, really well. So what else? What other low-powered devices do we have? So loads of surveillance cameras now run WebRTC within them. Your Ring doorbell, for example, / any other doorbell. That's all WebRTC. In the very early days, it wasn't WebRTC. It was like SIP and RTP and without any encryption to a degree. But times have moved on. And so you buy a surveillance camera that is Wi-Fi, and it's probably running WebRTC. Baby monitor cameras, etc. And so these are running on, quad-core, 1.2 gigahertz, like super high power in the grand scheme of things into this little device. A blast from the past. Stadia Chromecast Ultra and the Stadia controller. Did you all know that was actually WebRTC? So the Chromecast Ultra had a hardware decoder in it. It was Wi-Fi connected, and it dealt with up to 60 frames per second, 4K video and audio. And that was all delivered over WebRTC. That's kind of cool, right? For me, it was the controller that was the more interesting thing. The controller had a microcontroller in it and did connected up to the media server that was running the game over the data channel, and you controlled the game directly. So Wi-Fi gamepad, WebRTC data channel, and it was a direct connection to the cloud. Dan, this is all very interesting, but how is this actually interesting at all? So let's take a look at the here and now, right, instead of looking at history. So for me, playing with hardware is fun now. 10 years ago, I looked on at Tim and went, I could never do that. That's ridiculous. But now you can go and buy devices that look like this, and they're self-contained, and you can, plug things in, but you can start hacking on WebRTC on a device that's super tiny and not that expensive at all. So let's take a look at now. Raspberry Pi microcontrollers. So this one here is an Interstate 75 board from a company called Pi Moroni in the UK. But on it is a RP2350 chip from Raspberry Pi. So that's a microcontroller. And you can run data channel on that chip. So they're extremely cheap, but very problematic. So they've only got a 150 megahertz system clock, so even less than the EV3, but it's a dual core, not, so let's say it's about the same, yeah? And it's got 520 kilobytes of RAM on it. There you go. I think I missed something on the bottom. So there's no connectivity on it. It's just a chip. It's just a microcontroller. And they cost about 90p each. So that's pretty cool, right? You can buy a chip. Sure, you have to make your PCB and everything, but the actual chip that does all the hard work is 90p. You then have to buy an RM2 module or a Wi-Fi module or whatever, and then that will give you connectivity. That chip is about £4. So let's say £5, right? That's buying it and putting it on a PCB yourself, et cetera, et cetera. But that's, no one wants to do that. So you can go and buy yourself, I can't really hold this up. Let's do that. There you go. So this is a Pico. It's actually the Pimeroni's version of a Pico, but you can go buy that, and that is about £7, £9, something like that. I can't remember off the top of my head. But yes, you can go and do stuff with it. I haven't tried with media yet, but you can definitely start up a data channel. And there's a project called libpeer, and you're going to hear about libpeer quite a bit. So that's quite interesting, and actually quite cheap. But on to ESP32S3. So the ESP32S3 is what is in this, it's what's in this, it's what's in this, it's what's on this. So you can go and buy loads and loads of devices that are based off of an ESP32S3. So the specs for an ESP32S3, you can get different variations and things, but for the easy part, it's a dual-core 250 megahertz processor, and it's got 512 kilobits of RAM, but you can add more to it. Why ESP32S3? So they are cheap, and they handle real-time media, and it's one chip that you can go and, like, it's not like the RP2350 where you have to like combine stuff. It's one chip. You can buy that one chip and go get started on it. So it does support audio, and it does support video, and it does support the data channel. And the libpeer project has support for it. But the company behind ESP32s, Espressif, have their own version now that is better supported. Public service announcement. If you're just getting started into hardware, you might hear people talking about ESP32s. Well, an ESP32 doesn't equal an ESP32S3. They're actually, very different. And there's a P4, there's an S2. Anyway, the one that you want to be looking for, the one that's really well supported within the ecosystem, is the S3. So yeah, super important. You can't just go buy any random ESP32 and expect it to work. Yeah, so lots and lots of devices, like I say, that you can go and buy, ready-made, and play with it, which makes it really, really accessible. So the things that I held up here, these are all from a company or a project called the M5 Stack. And so this is a cardputer, and this is $40. This is a Atom S3R. This is not the camera version, but there is a camera version that's $24. This version is $21. You can literally go and plug and play. So this is the M5 burner application, and literally you go and download an application such as the OpenAI voice assistant for the Atom S3R. But I'm actually going to use this one. And you can just, plug it in and, shove a program on it, and then it's on there. So it's plug and play. Let's see whether or not I can... there we go. So I've put the ChatGPT OpenAI app, and hello, OpenAI.
Hi there.
How are you today?
I'm doing great. Thanks for asking. How about you?
The Wi-Fi's not great. But you get the idea. I literally went and downloaded M5 Burner, plugged it in, pressed burn, gave it an API key, boom. This little device here is talking to OpenAI's real-time API. That's pretty cool, right? So plug and play, blah, 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 right. Yeah, M5 Stack and OpenAI. So yes, you can go and build with the ESP32 with the OpenAI real-time API. Pipecat is another project that kind of helps deal with LLMs and things with WebRTC, and the Pipecat project also have a load of images already made for the M5 Stack. So you can go and build a $25 chatbot. So demo maybe. I should have removed the maybe. I've just done the demo. So that's really quite cool. But what else? Earlier I mentioned Dotty boards. Dotty boards are a product that we sell, and they are an LED matrix, this one here. The ones we sell aren't broken. I take my broken one with me when I'm traveling. This here creates a Dotty board. And we currently use a Raspberry Pi 2350, but we're actually in the middle of migrating to an ESP32 ecosystem. So it shows data related to a hobby. So this is our first version, and anyone from the UK knows who the RNLI is, but they are our lifeboats, and they're a charity all over the UK, including Ireland. And this board kind of lights up and tells you stats and things like that. When this picture was taken, the RNLI had gone out 6,890 times this year. It's more like 8,000 now, I think. And this is hopefully a video. I need to hurry up. 4 minutes left. There you go. So we push down events, but that all happens over WebSockets. And we're in the process of moving to an ESP32 ecosystem. And like I said, I'm not used to this new app for slides. So like I said, we're starting on the ESP32 journey. I hate that word journey, but I'm going to use it anyway. So we're in the process of making our own PCB that we own everything to, and it's been a mega journey. I've used the word journey again. I apologize. It's been a huge challenge for a non-hardware person like myself. So yeah, I got interested in running WebRTC on ESP32s because I could, and like this is what I do for a job. And so I stupidly put a talk into a conference about running WebRTC on low-powered devices before I'd actually got WebRTC running on a low-powered device. It's a great way of like incentivizing you to go and learn something new. So I was talking to Tim Panson about this, and he said, I want to see your Dotty boards running WebRTC, using WebRTC to deliver. It's completely over the top, completely unnecessary. We don't need real-time integration into Dotty boards at all, but it sounded like a fun challenge. So that's what we did. So this is, well, I say that's what we did. I kind of got halfway there. So this here is an ESP32 S3 dev kit. And so you can see I'm plugged into the board. And if I plug it in to the power, so let's plug the power to the display, and then I should have another USB-C cable here for this. This might go terribly wrong. I will warn you. So hopefully that board's just lit up with a yellow line. Yeah, great. So let's trying to do this without being able to see what is going on is challenging. So let's close that. M5 burner, we don't need that. And then, here we go. Right, so I'm gonna monitor this device, this ESP32, and I'm also going to go back to this website that doesn't look at all like AI generated it for me. So if I connect to the signaling server that you can see is running in the background there, and then it's connected via a data channel to this board. So hopefully, if I fill it with red, yeah, right? So the setting up that session happened over a signaling server because it has to, right? WebRTC isn't magic. We still need that thing that passes those messages. But I can turn off that signaling server, and I can still, control this board. So it should be blue now. It should be green. And then if I, let's clear the canvas and let's clear the screen, and then we can draw on my canvas up here. And hopefully if I press center LEDs, it's going to magically appear, right? So we're mapping all of those pixels on this canvas, this HTML canvas, and we're saying, oh, that's 0, 0, that's 0, 1, right? And then we're sending those to the board. Shush, shush. Is it fixed? Anyway, should be like that, shouldn't it? Anyway, so that's all happening over WebRTC from my laptop to this board right here, and up until earlier this week, none of this existed, and that's how good the ecosystem around this is now, and that's pretty damn impressive. So if I go back to my talk, right, done the demo, and it went semi-well. So data channels go over to the live pixels, and the WebRTC is powering a private real-time interaction with the Dotty board. It's not quite as finished as I'd hoped. I really wanted to get, the country outline and alert, but I ran out of time. Bad Dan for not starting earlier, but it is what it is. But yeah, what a journey. I'm sorry again. How is this helpful? I'm now over time. How is this helpful? I told you, I was going for fun, but what is the future? The future is AI. The future is WebRTC in edge devices or media MOQ, MOC, not media over quick. We've been told it's not media over quick anymore. It's MOC. It's this all at the edge. So cheaper chips, better SDKs, 5G everywhere, so you can, you don't have to be connected to Wi-Fi, and you can contribute and consume anywhere using WIP and WEP when it comes to WebRTC. The takeaways: hack, share, inspire people. Thank you very much. The shout out, Tim Panton, Expressive, Sean Dubois, because he really encouraged me, and the PipeCat team for everything that they put out open source. And then you can reach me on X, Mastodon, Blue Sky, LinkedIn, everywhere. And that's my email address for anyone that still uses email. That's it. Thank you very much. I was only 2 minutes over. I'm pretty happy.
Yeah, it was worth it, I would say. Okay, we obviously do have time for some questions. Anyone?
So can I connect a camera to this ESP32
Yes.
and stream via WebRTC?
Yes, so this one here, this M5 stack, I can't remember the exact name of it, but it's like, I think it's called a Core S3. This has a camera built into it. So you can literally go and play with this today and get video and audio streaming out, and you can play. It might not be the best video, you can play video back on the screen as well. So yes, absolutely, you can go and you just build stuff today. Finding the docs and things is a bit challenging. I'm going to write up a blog post after this of the challenges that I faced in the week that I've been doing this. I hope that answered the question.
Thank you.
Any other questions?
Who's going to go buy a device and tinker? I have one hand. I've won with the one hand, so that's great. 2 hands, 3. Do we have 5? Anyway, yes, great. Okay, thank you very much.
All right, let's wrap it up with a round of applause.